In this video, I'll show you how to do a very simple version of the Unit 3 project. If you want to get some extra points in your script, I'm happy to meet with you one-on-one to look at importing the non-formatted file or doing a complex filter, but I think this will be a really great way to get you started, no matter which version of the project you're doing. So to get started on the Unit 3 project, the first thing you're going to want is to open up RStudio and start a new project so that you have a fresh folder where you know exactly what is in that folder, what's available to you, and you make sure that you have all of the data files that you need. So that new project, I'm going to start on the desktop, and I'm going to call my new project Unit 3 Example Project. Create the project. And as we work through each part of this project, you're going to see that you can reuse a lot of code from other homework assignments. So a lot of the things that we're doing in the Unit 3 project are identical to what you've been doing in the homework. In order to get started, we need a file that has all of the raw data SNPs for all 960,000 of John Wilbank's SNPs that were tested on the 23andMe chip. So if I go to our shared folder on Dropbox, you'll see two versions of the file that have long file names, 615.23andme, CSV, and text. But you'll also see a file called formatted SNPs. That's the one I want you to start with to be able to do this project. So I'm going to copy this from Dropbox. You may download it through the web browser, and I'm going to open up my Unit 3 example project and paste the file. Now I'm ready to start writing my script. So the first thing I need to do the Unit 3 project is write my name and the date. Today is April 9th, 2020. And we need to read in the raw data file. So I can read it in the same way I have the first 100 SNPs file. Instead of calling it 100 SNPs, I'm going to call my variable all SNPs. And I'm going to read in the file called formatted SNPs. The easiest way to make sure I type the file name correctly is to use the tab key. That way I can select the name and run that command. And you'll see that it takes a few minutes to run this command because it's a large file. Now that the file has loaded, I am ready to do the next step, which is come up with the list of SNPs that are related to my disease. I'm going to show you the easiest way to do the Unit 3 project in this YouTube video, but there are lots of other ways to do it. You could do a Biomart search and read in the file. So if you did the Biomart search on the website, you could do a Biomart search in R, or you could go to a website like Prometheus and download their report. So that's what I'm going to do, just to show you how that works, since it's not something we've done in the homework. So get list of SNPs related to a disease. So what I'm going to do on Prometheus is I'm going to look up a condition that I don't think any of you are going to want to do your project on. I'm going to go to ClinVar diseases. I'm going to scroll to near the bottom of the list, and we're going to look at vitamin D dependent rickets. This is a disease that people don't get very often because most people have a sufficient amount of vitamin D in their diet, but it can result in people having an unusual growth of their bones. So vitamin D dependent rickets is right here. And we can see that there are 3 genes that are common in ClinVar that are related to vitamin D dependent rickets. And we can open them up in a table and actually download that table to the computer. So I could get these SNPs into R in 2 different ways. The first way would be to use the C command. So I can copy directly from that table into R, where I type the list. And I'm just using the copy and paste function to make sure that I get the exact number. And since you only have to get 10 SNPs for your Unit 3 project, somewhere close to 10 SNPs, so 8 to 12 SNPs, this is an option. You really can type out all the list of SNPs related to the disease. Or another way to get the same list of SNPs is to read in the SNPs. And we can do that in 2 steps. Step 1, go to Prometheus, download the table as a CSV table, and open it in Excel. In Excel, we can now format these SNPs. So I'm going to make a new spreadsheet to format the SNPs and get rid of the information that we don't want. So we want the SNP ID, but we don't want the genotype. I can get rid of that by going to Data, Text to Columns, and I'm going to use a delimited filter to get rid of all of the information after the opening parenthesis. When I do that, I can now get rid of the genotype. I can get rid of this row that has a column header, and I can save this to my project directory. So my project directory, if I go to Browse, you can see that my project is called Unit 3 Example Project. And I don't want to save this as an Excel sheet. I want to save it as a CSV file. So I'm going to call it rsids.csv. You can see that it looks a lot like the rsid.txt file that we made for our homeworks. Saved it. And now I'm ready to use it in R. So those are the 2 ways that we can get RSIDs. I'm going to make a second variable for this, just so you can see that the 2 variables are the same. It's called myRSIDs2. And the way that I get it into RStudio is I use the R read CSV command to read in rsids.csv. Now, unlike the data that we read in from 23andMe, this does not have headers. So I'm going to set header equal to false to be able to read in all those values. And I see that I get a data frame with the same information that appears in the myRSID list. So either approach will work. Whichever one you want to use, you can use. And now you're ready to run a Biomart search and get information on those SNPs. I'm also going to save my script so that I have it available. Now, I could look up each individual step, but I know that I've recently run a Biomart search. So instead of looking up each individual line of code, I'm going to go to Open File, and I'm going to go on my desktop to the folder where I completed the Boolean assignment. And I'm going to open up the Boolean script, and I'm going to copy the lines of code for doing the Biomart search. So we can see that this loads the library. Once the library is loaded, I can change my ensemble data set and set up the ensemble mart for the SNP mart. I can set the attributes to the attributes that are required by the assignment. And then instead of first 100 SNPs being the SNPs that I'm going to look up, I'm going to look up this new list, my RSIDs. When I run the search results, I'll get a data frame that is only 3 rows long because I only had 3 SNPs. For your project, aim to have more than the 10 that you need. Try to do something like 20, 30, 40, 50, so that it's a small enough number that you can look through it, but it's a big enough number that you'll be able to filter the results. So I have 3 observations of 4 variables, and I'm going to see how many of those SNPs actually appear on the 23andMe data chip. So I'm going to merge 23andMe results with the results for Biomart. My merge is a new data frame that I'm creating. I'm creating it by merging all Snips, search results, the column in all Snips is called RSID. The column in the search results is not called RSID, it's called refSNPID. We can run that command to create our new data frame. So we've gone from a list of almost 1 million SNPs to a list of only 3. Now we have a merged data frame that combines the information from Biomart with the information from 23andMe. This is almost the end of the project. For your project, you're going to filter them if this list is longer than 10 SNPs. Since our list is short, it's only 3, we can just write the file. So the final step here, because we don't need to filter, will be to write our file that we're going to use for the project. And we can do that with write.csv. mymerge.csv, row names equals false. So our final output for the project is a list of SNPs that have information that we're combining from the 23andMe results with the individual's genotype and the data that is downloaded from Biomart. You may have something that looks like mine, where the data is empty. And that's where the homework assignment on researching clinical significance beyond Biomart will come in handy. But this is all you need to do for the Unit 3 project. The Unit 3 file is commented and ready to pass in, and mymerge.csv is complete and ready to pass in. I hope this video helps you get started.